Hi friends, we are going to see a new white paper in AWS, which is Data Lake on AWS for gaming. So the reason I choose this white paper is to understand what is data lake, because now data becomes the more valuable or critical solutions like data scientist, data uh, mining or data warehouse. So there is a lot of concepts around data, data like database. So today, AWS has published how to build a data lake for a gaming platform, because in gaming is a huge platform where more number of players will play it. But here we're going to touch upon what is data lake and uh, know how we need to first understand the basics and understand what is data lake and how we can build the data lake. So without further delay, let's start going into this white paper. So here we could see the data lake, kind of one of the uh, major thing in well architected review. What is data lake? How it does benefit game developers? Data lake design patterns and principles, frameworks, 10,000 foot view, 5,000 foot view, 1,000 foot view, data lake warehouse architecture, data ingestion, data transformation, data cataloging, data lifecycle management, workflow orchestration, data security and governance. These are the very key topics, and we also can see some of the topics like data visualization, monitoring, cost optimization. Let's see how, let's learn together how what is data lake. So now you can see this paper is focusing on the gaming sector. Like we have hospitality, we have insurance, we have banking, but this is majorly on game developers. But it doesn't matter because we just with this use case we going to start. Many customers run their digital games on AWS. Each of them has made unique design choices that allow them to run faster, most complex, visually breakthrough games on AWS. The outline of best practices of building a data lake for games on AWS Cloud and offer the reference architecture to guide organizations in order to deliver the complex system. So this is abstract where we already understand about this. So these are some introduction about why gaming platform need big data lake. Basically, if you see the in gaming, it's a real time streaming kind of like when you used to run, when you used to jump, it should happen in the real time without any delay or without any no without any lag. So that is really a performance. So that is why they are saying understand the player behavior and business performance, enable timely and data driven decision making. So when they say data driven decision making, you are going to first level, second level, third level. So based on each user, each game, there will be a decision making. Today, more and more game developers are building data lakes on AWS to achieve the business outcome. So this is why they build this data lake. But before go into it, we need to understand what is data lake, right? So a data lake is an integrated and centralized data platform combining data storage and governance, analytics, machine learning, and visualization. It is secure, durable, and cost-effective cloud-based storage platform that allows you to ingest, transform, analyze, and visualize structured and unstructured data as needed. Okay, so basically, to make you understand easily, if you see there is an ocean, like in ocean, and there will be different lakes if you see any map, right? And all these lakes goes into ocean. Okay, and these lakes are formed by different sources. Like it comes from rain, it comes from different sources. So actually data lake is kind of getting the data from different data storages. You can have data in MySQL, you can have data in Oracle, you can have data in like MS SQL, but all these three data can be collected in one data lake. Okay, that is why they are saying centralized data platform coming. So you no need to integrate with Oracle, you no need to integrate with MySQL. Both the data will available in the data lake. So you can take the data from the data lake as one central data platform. So by doing this, we can achieve the governance of data in one place, analytics, machine learning, and this also be more secure because you secure the data lake part, and it's more cost effective as well because you are not going to rely on one storage system to store your entire data. You can have multiple storage systems, but you can access all these storages via one data lake. Okay, so I hope you are getting that idea behind the data lake itself, because the source of data can be anywhere, any data storage, but data lake collects the data and keep it in one place. So it is integrated with all data storages and keep it in one place for governance, analytics, and no, it is also easy. For example, here using a S3 based data lake architecture capabilities, game developers can achieve the following. S3 is simple storage service like you use Google Drive or iCloud. So similarly, S3 is service which stores the data in form of objects. So here they want to give S3 as an example and show what is the benefit of data lake. So ingest data from a wide variety of data sources using the combination of batch, real, near real time and real time data ingestion. So now you think S3 as your data lake and you ingest data from different data sources to a S3. Store injected data in cost effective, reliable and centralized platform. Now you are storing the data injected from different databases. There is some databases called time series database. There is some database is SQL, some database is no SQL. So those are different format, but you inject the data and keep it as one central platform in S3. Build a comprehensive data catalog to enable easy access of data assets stored in the data lake. So you should have a catalog now, since you are storing all data in centralized place. Now, when you create a catalog, data catalog, it is easy to choose what data you want to take it to enable the access basically. Secure and govern all data and business metadata stored in the data lake. So basically, it is so secure because we govern all the data in one central location, monitor, analysis, and optimize cost and performance. So this all can be done in one place. Visually map data linkage. So you can map the data, even though the data is from different sources, you can map the data for different analytics. Transform raw data assets into optimized usable format and query them in place. So still you can also have raw data. So this data lake is kind of a raw data. You can use in any usable format and query them. Easily and securely shared process data sets and results across your organization. So the main source of this data lake is to make this data shared across uh, different places, right? Use a broad and deep portfolio of analytics, data scientist, ML, and visual tools. So data lake helps in data analytics. So you have all data in one place, and data scientists to do their own data scientific, like they have some metrics to find how much production you have to do today. Like you can make only 200 cutlets or 200 samosas today. So better on that is the data scientist part. Using machine learning is an algorithm, and then you can visualize your data in different formats. Quickly integrate current and future third-party data processing tools. Yeah, so since you have a data, you can integrate some third-party data processing tool. Subscribe third-party data in cloud, load data directly to the data lake and analyze it wide where analytics and ML. So you can also have third-party data tool to load the data to your data lake. So I hope fairly we understand the concept. The data lake is one central place for accessing your data, even though your data sources are different. When I say data sources are different, it's your different databases. Like it can be any databases or multiple database where we collect the data into one place called data lake. I hope little bit clear. So they also says S3 decouple storage from compute and data processing make it so S3 itself is a service, so you don't need to write have a different compute storage or different CPU RAM. It's itself a service, so that's what they are trying to say. Data lake design patterns and principles. So this is very important. Now we understand what is data lake. Now let's see the high level framework of building a data lake on AWS. So they say 10,000 foot view. So source systems is where your data is. You need to extract, transform, load, extract, load, transform. So ETL, extract, transform, load, extract, load, transform. By these methods, it go to your destination system. Your destination system can be anything like so basically, the 10,000 foot view is they are telling like you are in helicopter and you watch your ground. So if you are on 10,000 foot, like you are on 10,000 foot, you will see a small dot of a building. When you come to 5,000 foot, you will see the at least the balcony and garden of that floor. When the helicopter goes below, then you will see much better. So that is where these different views are. So now when we see from 10,000 foot view, we see a data source. We need to extract load transform or extract transform load to the destination system. When we come closer to 10,000, 5,000 foot, so now we understand there is something called data producers, data streamers, data collectors, data aggregators, data transformers. This goes to data catalog, data analysis, and data consumers. So here we have different terminologies or different people. So who is the data producer? Who is the data streamer? Who is the data aggregator? Aggregator means you get one data and you get it like APIs. Data collectors. Okay. So the three major things are data catalog. We saw why it is needed. When it is in data lake, to access the data into data lake, you need a data catalog. Data analysis is nothing but the analytics we keep on this data. Data consumers is the who wants to use the data from the data lake. They are the data consumers. Okay, so let's see we the 1,000 foot view. So when it comes to 1,000 foot, the helicopter is very near to the building. You can see much more things very clear. So the data sources such as game servers running on EC2, Outpost, containers, and so on, you can also use S3 as a primary data store, then send the data downstream. So source can be a virtual machine, VM, that is called EC2 basically. From there, it will go to data streamers or data aggregators, data collectors, data transformers. So there's two workloads. One is the streaming workload, another one is the batch workload. So if you see when we say data streamers, we need to use Amazon Kinesis as for data streams, and then Amazon MSK as a Kafka, the distributed. Like if you guys are familiar with this distributed like big data, right? So there they use this Kafka, Zookeeper kind of. So Amazon has their own managed Kafka. Data aggregators is AWS Glue Service, AWS Lambda, AWS Kinesis Data Analytics. So these are any of these services you can use. Data collectors, Amazon Kinesis Data Firehouse, Amazon S3 Storage Gateway, AWS Transfer Family, who collects the data from here. Data transformers, Amazon EMR. EMR is it's like a registry, LS, where it stores all the images. AWS Glue or AWS Batch. So basically, these are the different AWS services which are available in these places. When it comes, then it goes to governance. Governance, we have AWS Glue Data Catalog, and also AWS, Data Lake, AWS Lake Formation, and Amazon S3. If you are a data scientist, then the service are EMR, and then Amazon SageMaker. SageMaker is mostly the machine learning service in AWS. So then we have, sorry, I have said like we need to store containers. That is not, there's EMR, that is ECR. Sorry for that. So EMR is again a machine learning service. Then we have a data analytics. It's Amazon Athena analytical service where you can query to the database with your queries. Amazon Redshift is your catchy database. For visualizing, we have a third-party tools called Amazon Quick Insight, where you can create your own dashboard, personalized dashboard for each users and see the graphs of the data. So basically, if you see here, we have multiple services in AWS put together to build a data lake concept. So I can see data lake is a concept where we need, when we build with multiple for example, cloud computing is not a service, it's a concept, and we need to use AWS to put our data on cloud. Still our data can also run in on premises, right? So similarly, data lake also seems like a practice or a concept, but we need to build it with many services in AWS, and it will be useful for the the current trend. There is a lot of boom on data scientist role. So when no, when you are data scientist or you want to make data analytics for your company, data visualization, then you need to have data of all your applications or all your application teams data. Each application team will use their own databases or data sources. So you build a data lake, get the data from your applications teams or the different sources, and you do the analytics and visualization. I hope we are getting little bit understanding on the concept of data lake, but we will see it little bit more. Lake house architecture. So game developers often use data warehouse alongside a data lake. So they say they have used data where data warehouse can provide lower latency and better performance of SQL queries working with local data. That's why one of the common use case for data warehouse in game analytics is building a daily aggregations to be consumed from business intelligence solutions. Games can generate lot of data, even logging activity down to keystroke. This can result in having processing terabyte of data every day, and data may reside in or need to loaded into different data stores. These data stores can be such as Amazon Elastic Cache for Redis or relational database like Aurora, NoSQL database like DynamoDB, and log data partially stored in S3 as well. The challenge then becomes having a management of data and find the way to get meaningful insights throughout your repository. Whatever we discussed till now. So they are using data warehouse to get the data, but it provides lower latency. Um, so, but data in gaming is like when you click the button, when you run like multiple users, the data can be in different sources, and we need to have a meaningful insights of different data. For example, DynamoDB performs well for specific use case such as reading and writing a data with single digit millisecond latency, but it should not be used as a source for your analytic queries, as there is no one tool that is perfect for every job. Having a lakehouse architecture allows customer to easily move data to and from their data stores in fast and secure manner. This allows customer to connect their data lakes to the databases and warehouses using the AWS data catalog, which is integrated with many AWS services. I think now we are getting closer to the concept, right? DynamoDB is serves one use case, but you cannot use DynamoDB for everything. Then you need to do you would use different data stores. Then in that case, you can connect your databases and data warehouses using the data glue data like data catalog. Instead of building a siloed data warehouse, you can use technologies to integrate data lake with it. For example, use Redshift Spectrum to query data directly from S3 data lake, or the Amazon Redshift copy command to load data from S3 directly into Redshift into parallelized way. Many customers don't want to have a load 10 or 20 years worth of data into a data warehouse when they rarely need to query it. Extending your data warehouse to data lake is a great option in this case, as you can keep your historical cold data in data lake to save your cost and use your data warehouse to query your data lake when necessary. So we are using data warehouse for a long time where all data are stored. So data where instead of putting everything to data warehouse, we create a data lake where you can put your 10 years, 20 years data, which is hardly you require when there is some compliance issue or when you want to check something, hardly you check one or two. So data warehouse is comparatively cheaper to data warehouse. That's why when we want to check the data warehouse, now data warehouse is checked with the data lake to get the data and it serves. I think it's really interesting because now I understand how it saves the cost and why we need data lake for saving the cost as one thing. Now you can see very interesting diagram. This makes it very clear that the center one is your data lake, and you can see big data processing, log analytics, data warehouse, SageMaker, DynamoDB, all different data sources. So EMR is for big data processing. It's called elastic mapping relations. Forgot. So now this picture clearly makes us to understand different sources of data can be centrally stored in data lake, and we can connect to the data lake to get the data and process it when needed. Very good diagram. And then this is the lake house architecture, data lake house architecture. Now we understand. Now the part is now we are going to inject the data ingestion. So game developers collect and process different types of event from sources. Typically, typical examples include marketing data from the game and third-party services, clicks. When you click, install, impression, and because it's a business, right? If you have an online game, you need to make the analytics to develop your game based on the users' interest. Before you transform and analyze this data in data lake, it need to be injected a raw region of data lake, right? The data should be available in raw format in data lake. So this chapter discusses the data ingestion mechanism and design choices. So now I'm going to go little bit faster because I'm going to give this white paper link in this video. So my like the reason I do this white paper, even though the gaming is not a key for me, but to understand this data lake, whenever we talk in IT or we go for different uh, solutions, we need to aware of what's happening and what is the new thing in market, right? So now I'm going to go a little faster on very key topics. I hope we understand what is data lake and why we need to use it. So let's come to data collections. So data collections is collecting the data from the different sources and have it in your no have it in your storage. For example, it can be the gamer who collect the data like mobile services, app flyers, third party mobile trackers, amplify Google Analytics, and inject can be depend on third. So the data can be also from third party provider, like you have a website and you have a Google Analytics. So Google Analytics collects how many users is coming to a website. So those data can be injected with the third part, that is a third party service. Streaming and batching. Streaming, everyone knows, like when you watch YouTube, it likes to the audio or video itself is a data. And when you play that audio or video, it is stored somewhere, and it it is processing it when you watch. So that is where the streaming or batch job comes. Batch job is kind of loads the data. Like when you see the loading button, it used to process the data from the data source. So it can be done with Amazon Kinesis data streams. So there you have data lakehouse, and you should have the Amazon data stream where it connects the data and it streams for thing. Injecting every single event is inefficient. It generates excessive network traffic and might lead to high cost. So every time you want to connect to your audio or video, like it makes 1,000 connections for that video. So we want to avoid that, and we need to have something that is kind of a streaming service. That is where the Kinesis comes. So you won't connect to the data. Kinesis connects the data for one time, and Kinesis creates multiple connections with that data from the data lake. So this seems to be very, we don't need to discuss more, at least. Client or server. So depending on the architecture, the game, like you can be a client or you can be a server. So when I say client, your mobile might be a client where you watch the game or you play the game. And when we say a server, you might be using a third party SDK, or uh, you used to take that API of the game and you built your own game. So like the game is already there, but we built one more small game. So then it became server. So those cases, they use this REST API. So you can use the API from the database or data lake, and you can inject. So where they already told we should use Kinesis or Kafka. So and then with the API in front of the stream. So API where you can build based on this game, you can build multiple games. So if you guys understand, like know about API, you will understand what they are trying to convey us. So what are the other sources like Ethana, as I said, DBS, database migration service? They just given what are the other data services. Data transformation. So these are something I'm going to skip now because we are not going to see in detail. So here you can see the data sources where we connect to the data lake or data warehouse. So from there they use the Glue Data Brew service, which is the virtualization service. And here is the S3 to publish the data and insights. So basically they try to give one more service called Data Brew, which helps to normalize your data. So now when you want to make analytics, so the data is from different data sources, right? So to make your data in a normalized, to make some preparation to show it in visualization. So brew, so like preparation, data preparation. So that's why this data brew is coming to the picture. So we are seeing a lot of different AWS services put together. Data cataloging. So this is the component where it is used in governance as a central technology, where you see all the data for where it is. So that it can be also called as metadata. So for your, like if you have the catalog will have all the metadata available for your data stored in your data lake. Now let's see. So we have different data sources. RDS. RDS is very, a lot of people, if you are in AWS, use RDS, DynamoDB, Redshift, S3, or even JDBC Java connectivity. So here you can see where they use one service called AWS Group Travelers to interact with these data sources and also with other elements. So it writes the metadata to your data catalog, and you, if you see here, it also connects to the data storage using the connection and the schemas or classified here. So data crawler does it, and then the metadata stored in data catalog. From the data catalog, we used to use it. So there's another service which is called data to crawler. So you don't need to remember all these services when you are actually trying to do data lake, or so these all services also used for different purposes. Data lifecycle management is very important. How the data is created, how it is managed, and how you're going to do it. So here they have choose the S3, which gives 99.99, which means level 9s, because there can be deletion of when it becomes, if you are adding one record and if you are reaching 9, there can be deletion of one record kind of. So data durability. So S3 has a different S3 as well. S3 standard, infrequent access, glaciers archiving. If you want to keep some time for archiving, that is, so this is different variety of S3 they have. So here in the data life cycle, they want to give two things, like it manages your storage in transition action and expiration action. What is transition action and expiration action is when your data is going to delete, or what is your retention period. So the predefined retention period, if you want to retain for 1 year or 2 year, based on that you need to choose your type of the data. So that is where they want to empathize the retention period of your data. Workflow authorization. So these are different services. Like when we want to do workflow authorization, we use AWS step functions to make it automated way. Like you want to create a data lake. Now we know how to create a data lake. But instead of you do it, you can generate a code using the workflow tool from start to end. You can see a start and end here. And from the start to end, we need to create all the steps and execute from this service. So this is a AWS MWAA architecture, which is nothing but they include different services like Ethana, Batch Jobs, DynamoDB. So there is different ways where you can create a data lake for different reasons and different architecture. And you need to do data governance, GDPR. If you are especially in Europe, you will like HIPAA, GDPR. So how you save your data, like you should not have your personal identifying information, PII. That is the key criteria of data. So you need to scan all the data into data like to identify the participant that contain the record. So before the data goes into data lake, we need to scan to not breach the GDPR and those things. So these are some guidelines they have given. So I hope there is cloud formation, which we use it for creating your compute component. There is something called lake formation. So this lake formation is stack where from S3, when you click the lake formation, it does the ELT, which I said, no, the load preparation, data catalog, data security, access management. So AWS wants us to keep these things very easy. Ethana is for storing your database, Redshift, and then EMR. Then it goes to ESR. So data lake formation is kind of manage all your tasks related to data warehouse. So we have discussed a lot of services, but if you want to create your data lake very easily, then you should use the data lake formation. Data visualization, as I said, it's a BI tool, business intelligence tool, which we have quick insights. Quick insights have the integration with your data lake, and you can make different dashboards and things. Monitoring, we use CloudWatch monitoring, which is default AWS monitoring system. So I hope this article is little bit new, but I hope you have understand what is my main criteria here is for you to understand the technology of data lake, why we use it, and how AWS services can help us. I hope this white paper is useful for you. I give the description the link. See you guys. Bye.